Today we are going to discuss the system design problem for live comments or comments on the live videos that are there on Facebook, YouTube, Hotstar, like other places. More of these problems are simple enough, like similar enough. The our core motivation is, or like the core problem that we are trying to solve is on a given particular video, live video. The users are commenting live, and whoever is there, they can see the requirements. One would be like users can post their comments. The second one would be users can see comments posted by others in real time, right? And then users can see the historical comments also, right? So these are let's say are simple requirements that are there. We'll not go into the emojis and all of those things for some, right? That we can expand it. We'll keep the problem simple enough. Here, one would be because it's at the what do you say, at the Facebook scale. So one of the requirement would be like this system is supporting, let's say, millions of users, maybe the millions of videos, right? And the comments could be again in millions or billions comments, right? The second one would be here, like in terms of the NFRs, I would say the here I would focus more on the availability as compared to the consistency. It's fine if we see the if the it's fine if the comments are eventually consistent, right? Uh, because by the nature of the problem that is there, as long as the users are able to see the comments or post the comments, it should be fine. The system should be highly available as compared to the consistency. Consistency could be the eventual also, right? That's there. And then the third thing would be latency should be low. Latency should be low, maybe like less than 200 milliseconds kind of thing. That's when the data should be visible. So these are our like requirements, like the functional requirements and the non-functional requirements. Let's quickly go over the entities. What would be our core entities that we'll have, and this is like easier to follow this kind of structure. And then comments. Right now I'm not writing like all the detailed attributes and all of those things for these entities because we don't know like what all we'll be storing. So during the interviews it is fine, like if you just list down the core entities, and later on you can put all the required attributes and all of those things, because some of it might change as you kind of go through the design or based on the questions and stuff. Let's quickly also list down the APIs. Here this API would be simple. I don't think there'll be much. Let's say the post comments API. I mean, I'm using the CDP API, so it will have, let's say, the video ID. That's one, because that's how the comment we'll be making the comments, and then probably the message, right? Rest everything else we can have the right. This is there, and then all the user related information would be in the headers. I'm not going into that. You can also avoid it because it wouldn't give much there, right? And similarly for the getting the comments, I would like to have a get API, which is basically for a given video ID. It can give you the list of results, like list of comments, all the comments in a paginated way, right? So these are my like simple APIs. You can get started with this particular thing, but again, it's up to you. You should keep on kind of interacting with the interviewer if you are going in the right direction, if this is something that they're looking for. Here I'm not doing any estimations or anything. The major reason for that is because I mean, it's already a high scale system, and we are not going to get anything out of it. Whenever there is a need, we'll do the estimations at that time, because our system, we have already thought like it's supporting millions of users, so it's not going to give us much, so we can avoid that. But make sure that you are talking to your interviewer and telling him. So let's quickly start with a quick simple design, right? Let's say this is your client, whatever the client that is there. In the simplicity, let's just put a load balancer here. Load balancer, behind that there is, let's say, a comment service. You can just say it, but for the easier visualization, I'm making sure that I'm putting at least two boxes, just to make sure that it's a distributed service. There are multiple instances that are there. This is a comment service, and then what happens here is like client is making a call here. Let's say this is a create comment, or let me just put it like this. Let me move something like this so that it becomes slightly easier, right? Wherever you are viewing it, let's say you made a request for creating the comment, right? What will happen is the load balancer would pass this request. It will go to the comment service, and comment service would kind of put this into a database, right? Let's say this is my comments DB. db. Here, like one of the thing is coming back here, like based on the problem here, like very few users would be comment by the nature of the problem. Few users would be commenting, like they'll be creating the comments, but all the viewers, they'll be seeing the comments. So what we can easily say is like the posting comments is much greater than viewing the comments, right? What this means is basically our rights are much greater than the, sorry, are, it's the other way around. Basically what this means is posting comments, like very few people would be seeing the, like posting comments, but all the users who are seeing the videos, they'll be seeing the comments, so the reads are much higher. And what I want to do here is like I want to kind of, because our system is handling millions of videos and all of those things, I would want to kind of have uh, a database that is scaling, that can scale, and that has a planet level scaling and all the other things. And instead of, for simplicity, I'll just go ahead with DynamoDB, because that provides uh, all the things, like you can kind of uh, specify or fix like the or you can basically define the write IOPS, read IOP, read reads and all of those things, like how many reads it can support and all of those things. And you can basically scale based on the table level also. So for, I mean, it's available in other databases also, but for simplicity, I'll be kind of using DynamoDB. Again, like here, the reads are much heavier than the write, so we can make use of like the replications and all of those, like creating multiple instances and whatnot of just to support the read and all of those things. And here, for simplicity, let's just I mean, the one entity that one table that I'll define here would be comment, which will have the ID. Let's say the user ID. Probably the video ID, because that's the, and then I'll have content or message, creation time, right? Probably there'll be I'll create a secondary index here, also here on the video ID. User ID we don't need. This will be a primary key, that's fine. User ID we will not have, but maybe like we can create some more indexes on maybe the video ID, composite index on video ID and user ID. So we don't need to do the filtering based on the user ID, but the video ID based filtering would be there. So we'll have this data. This is our simplest workflow where the create command came in. The API goes here. It kind of stores the data, stores the comment in the DB, right? So that takes care of our first requirements. User can post their comments. Now the second requirement is, how do we see the information, like user can see the comment posted by others in real time? Or the different way of saying this is basically broadcast the comment to all the viewers in real time, right? All the people that are watching the video, we can actually should be subscribed, right? I mean that those should kind of see it. So what we would want to kind of do here would be the approach that I'm thinking of is without actually let me just quickly create these few. So what I'm thinking of is basically like this becomes a problem of publisher subscriber problem, right? Where as we are broadcasting the messages, like all the comments that are coming to all the viewers who are currently watching the video. So this becomes like, okay, this client is a producer, but all the viewers are nothing but the subscribers in a very simpler way, right? So that's what we'll be doing. For simplicity, like this is a subscriber PubSub module that is there, and then we'll have a, let's say, what do you say? Call it a comment broadcaster service. Again, let's say there'll be a, just to make sure, like it is again a distributed service. So what this is doing is this is kind of fetching it here, and okay, so this is what is happening, like it's broadcasting the messages to the clients, right? Now here this is a pub-sub where like all of these things are coming in, and that's how you are getting the clients. Users can see the historical comments also. Let's quickly solve that problem also. So there is a get comments, right? So this is going here. It's kind of going to the comment service. Again, we have right. I mean, this will talk to the comment service. It will fetch from the database, and let me just write it down for simplicity, right? Uh, fetches the comments from DB in a paginated manner, right? Let's say the sends the message to create comment. Right, these are my these are two APIs basically, like client. Ideally, these APIs would be here. They are going to the comment service, right? Or let me just kind of move it here rather than here, so that it becomes easier. Create comment and move this here, so that it becomes easier. It explains clearly. The client is actually performing that operation, and here that's what would be happening. Right, get comments. This is the simple workflow that I have right now. There are like a couple of things here. Let's kind of go slightly into the details of like what I'm thinking of doing here. So create comment is simple. Like let's just go through the functional requirement. Users can post their comments. So the requirement, the flow is really simple, which is it kind of sends the message to create comment or create comment. Okay, and here maybe like this is maybe like fetch the comments. Okay, so create comment is simple. It makes the API call, it stores it into the DB. The second thing that it does is it kind of pushes it into the publisher subscribers. Here we would want to have topics based on videos. The reason why I'm doing this is basically instead of having like one single topic for everything, that would mean like this comment broadcaster services, these are reading through all the messages that are coming, click all the messages that are coming into the topic, and then deciding like where to send it and all of those things. But I want to make it slightly more dynamic. So this comment service, what it is doing is stores the comment in the DB and pushes. So here that would be one more thing, which is pushes the comment into pub-sub, right? So this is these are two things that it is doing. We have gotten it in pubs in respective topic, right? Here it gotten it. Now what's happening here is like the comment broadcaster service, it kind of reads it and then sends it to the client. How does it send it? Like let me just kind of write it down here. How does server broadcast the comments? So the approach one could be using, let's say, creating WebSockets. What this means is like basically client creates a WebSocket and then it gets connected to the comment broadcaster services, and then server is sending the messages, and WebSockets are basically two-way connections. But here because our read is much higher than the write, which is the posting the comments is very less as compared to seeing the comments. So having two-way connection might not make sense. What we could do is like just use the server side connections so that we don't have to have the use the server side connection. This is basically the one-way persistent connection over HTTP, because here we don't, like, the client is not sending creating the comments in the real time. They are just, most of the users are seeing the comments, so it makes sense to just have like one-way connection which is on top of over HTTP, and that's where we'll use the SSEs. If it would have been a more of a real-time chatting service or something, there the WebSockets are making sense. So the pro of using the server-side events is more around like just have the one-way connection. It's over HTTP, so we don't need anything else. There is nothing else that we need to implement specifically for the WebSockets and all. So we'll go ahead with the server-side sockets also, like server-side events. We can create the WebSockets also, and but it will be slightly, I mean, not good use of the WebSockets because a lot of the messages are just coming from server side. So this could be one area of a deep dive where you can show the interviewer like you know more about the systems and not just at the surface level, but what are like best decisions that you can make. So here we'll be kind of SSE that is there. And another thing that would be here is like because the load balancers, if you take a simple load balancer, then it might just be doing a round robin and all of those things, and you don't know where whenever the connections are kind of getting lost, you are connecting to a different machines and all of those things, and these machines end up subscribing to all the topics and whatnot. So to simplify it, basically we'll use a level 7 load balancer, right? So basically the deep dive number 2 could be, which is basically level 7 L7 load balancers, because then you can have you can control where the connections are being made and all of those things in the reconnections and whatnot. In the server side events also, I mean, though it's over HTTP, but again the reconnections are a problematic thing here. Like clients can get disconnected anytime, but whenever they like though server would try to reconnect, but it may happen like the connections are getting dropped and all of those things. Coming back here, I mean, this is simple, which is we'll kind of create this server-side connection like one-way persistent connection, and these comment broadcaster services are sending these new comments that are coming in to the client. But how this is happening is basically like whenever client is making a connection, this connection is set. There'll be like these machine to user mapping would be there, right? So one thing that these like similarly, let's say the M2 is connected to U2, right? Okay. What this means is like this is just the connection information that we are storing. Now what might be happening here is basically U1 is watching the V1. So another mapping that we'll have is V1, how many users are connected, U2, U3, right, U4, and this is basically on the. And similarly, they could be like for the V2, maybe like probably U5, U6, right? These users are being. So this is the kind of mapping that we'll create when the connections have come in, right? So this will be with every machine would be kind of maintaining this map, right? So you can say like, okay, machine 1, like all of these instances that are there, they'll be having this, and this mapping would be there, so that we know like, okay, which all users are connected to me, right? This will basically so that the server side events could go to those many clients. What this does is basically, if you can see, this tells you for M1 this has like V1, V2 and V3 videos that it needs to subscribe. So what it will do is it will subscribe to those many topics, and kind of utilizing this mapping U1, U3, U4, it will fetch the comments if there are any, and send it to those respective users U1, U3, U4, U5, U9. And similarly on the M2, maybe like they are connected to V2, V3, maybe like V4, these are the videos, and M2 is serving the client all the things. And what happens in case of connection drops and clients connects again, right? For we are talking about the broadcasting. What it will happen is, let's say the client is, if it is connected to that same machine, probably you can utilize it, but this is the in-memory data, right? In-memory DB, in-memory store, right? So this, we are not persisting it in the database or anywhere, but it is more around just kind of here. So if let's say the client disconnects and comes back again, if it is connected to the same machine, it will kind of figure it out from these data. But if let's say the machine goes out and these clients are disconnected and they connect to something else, in that case what will happen is the machine would form this kind of map once again, and it will start fetching the data and start serving from there. So that takes care of our broadcasting, and it can support like millions of users, because now all of these things are highly scalable and all of those things. Though one problem could be here, I mean, so far I have used the PubSub, but for PubSub, uh, we can use Kafka or even Redis, right? Here, as you can see, like we are kind of doing the dynamic subscription. Sometimes even dropping the subscription, like whatever the dropping the subscription when the user is not let's say for a particular video there was like u5 u9 were there, though both of those their connections is close. Now we don't need v2, so we are kind of dropping the connections. For these two, Kafka is not really good. Like here, Kafka don't do really well here in these cases. So what we could do is maybe like Redis is more suited for dynamic subscription and all of those things. So we can use the Redis. Redis would be a better choice, but again it comes with a, what do you say, risk of losing data, because by default Redis doesn't provide the storage and all of those things. I mean, it doesn't persist the data, while in Kafka your data is persisted for some time. These messages are persisted for some time, right? So those are few things, but there are other variants of Redis that provides like active and all of those things in cluster Redis and whatnot you can utilize, and that can help you with the supporting some of the availability and all of those aspects also. So this takes care of our post the requirement, broadcasting the requirement. It is supporting millions of users. Consistency is like the system is available, because if anything goes down, there are a few other things. All our system are like horizontally scalable. Latency is again quite low because we have made it optimized. If it was one single topic for everything, then it might be slightly difficult. But with this kind of with this data structure and the approach that we have taken, it will be the message is getting broadcasted within like millisecond. Clients would see it, whichever are connected. That leaves kind of now comes back to our one requirement: user can see the historical comments. One way is fetch the comments, get comments that we are doing. It will have let's say the how do I kind of okay, it's going here. Yeah, so it will have the we can use the pagination and all of those things. But pagination, because the comments are coming in too frequently, pagination might not work with the default limits and all of those things. So what we could have is like we can use a server side cursor. That what that means is server side cursor for the so basically in the simplicity what we are doing is for the historical comment we are utilizing the API, the get API for historical comments, right? Cursor we'll use. So basically what that would do is like for every time it will kind of fetch the data from database. Again, like there could be one optimization that we could do is kind of we can have a cache instead of like doing that query again and again, which will be the call it a pagination cache. This is maybe like Redis. We can have a TTL also, like small TTL to update to make sure the data is not too inconsistent, right? So we'll have the small TTLs. What it will do is, let's say when the request came in, it goes to the comment service checks, like in the pagination, if for that cursor, like if there are the historical data is there, like what we'll do is like for a particular page or pre-fetched records, like 100, 200 or whatever the comments that we'll have for a particular video, whether they are there or not. If not, then it will go to Dynamo, like to the DB, and it will kind of get the data, put it into the cache also, so that the next time the request comes in, it kind of can serve it from here for some duration, like till the TTL is there. And that's how the create comment, like this client would get the request, like if people are going into the doing this infinite scrolling or like going through the request comments and all of those things. Here one of the few other areas of deep dive could be like where some of these topics might be quite hot, especially for the what do you say, the videos that are quite popular and stuff. But here this that we can kind of make sure like this comment services are the what do you say, the traffic could be distributed accordingly. I mean, there'll be one thing that we didn't do earlier was like for the server side connections, we'll need some ports. So every machine, let's say 65,000 connections per machine, so something like this would be there. And this we can make sure like the traffic is well distributed within the machines and all of those things. Distri Distributed well, right? The topic would have like lot many comments and stuff. I mean, the majorly it will be on these machines because the viewers would be much higher. The comments would still be less. The topic we can yeah, simply do it in a way that is kind of doing it well. Like, I mean, these topics would not have like too many messages, but even if they have, then we can create like further partitions and all of those things of these multiple partitions and whatnot, so that we can scale it up. Again, it's limited by the every machine would be serving like 65,000 connections because we are creating like server-side connections. But if here basically like we can create those many partitions of the topic, and that way like these machines can help us do that. So that takes care of all our requirements. User can post the comments. This flow looks like this. User can see comments posted by others. I think comment service process to PubSub. It goes to comment broadcaster service. It using the server-side events over a L7 load balancer, it reaches the clients. For the historical commands, we are leveraging the APIs that we have defined, and to serve the to make these requests faster, we'll be utilizing cache for the prefetched record. So that's how the system design looks like. Let me know how you liked it. If you liked the recording, please like and share the video and subscribe to the channel. Thank you so much, and also keep commenting on the videos. What else would you like me to record for you guys? Thank you.